essentially it's just those oxidation reactions from the aldehyde, from the alcohol to the carbonyl compound. It's the reverse reaction, taking a carbonyl, making it an alcohol. And then we are going to go over an addition reaction. Now, this addition reaction, I need you guys to be coherent for it. I need you to be coherent for the addition reaction. So let's see how far we get. The reason why I need you to be very aware of this and be with me is because this is going to be something from biochem. If you are going on to biochem, Dr. Narayanan is going to be doing this. And so I need you guys to be cool with it. Because what I don't want you to go on and be like, we don't know what this is. I need you guys to know what this is when you move on. It'll make your life way easier. And to help facilitate that, I will put examples from biochem into this course because the molecules that I have in here right now, they're not biochem. So when you go to look at sugars and how they cyclize, you're going to be like, because it looks totally different. It's just the nature of the molecules. Okay, let's talk about oxidation of aldehydes. We mean going from an aldehyde. So an aldehyde can be oxidized a little bit further. If we have the right conditions, that aldehyde can be made a carboxylic acid. Remember that, do you guys remember the definition of oxidation? Or how to keep track of oxidation through loss and gain of atoms? So for instance, what I mean by that is oxidation is gain of oxygen. Yeah, and you should lose hydrogens. Cool. And then reduction is just the opposite, right? So reduction is loss of oxygen, gain of hydrogen. So you can see here that going from an aldehyde to a carboxylic acid, you can see that there's a gain of oxygen, right? Do you see how in this, just look at this part, because that's the only part that's reacting. We've got one carbon, one oxygen, and one hydrogen. If we compare that to the carboxylic acid, do you see how it's different? Instead of CHO, we have CO2H. So we've gained a hydrogen through this process. I mean, yeah, we totally gained a hydrogen, right? No. What did we gain? Not a hydrogen. Yeah, we gain an oxygen. So this is an oxidation process. This process is so easy that if you want to keep aldehydes in air, this process just happens in air. Not even with help of a catalyst or anything, it just happens. So you got to be really careful. If we have an aldehyde, something like ethanol, and this is ethanol because it has 2 carbons and a hydrogen. If we do this in the presence of base, what happens is that the carboxylic acid cannot exist. You guys, did you learn about acids and bases in Gen Chem? Yeah? Did you learn about conjugate acids and bases? Yes? All right, cool. So conjugate acids and bases simply differ by an H plus. Remember that acids and bases react. They react in order to neutralize each other. They want to be neutral. So the way that they want to be neutral is by making a salt. But you'll notice here, what I have in the bottom right-hand part of the slide is that I don't really care. I would like you guys to draw this as a carboxylic acid. And that's because this course already moves so fast that I don't need you guys to keep track of, hey, this is basic conditions. But in case if you'd like to, you definitely can draw something like this. Or you can just keep it as the carboxylic acid. So I don't mind whatever you guys want to do, but you definitely can just keep it as the carboxylic acid. Are there any questions about that?
What do you mean? Like, in terms of what?
Oh, like if I were to ask what is the product